Hello friends, welcome back. Welcome to the concepts of CISSP. This is the place where we dissect difficult concepts and make it easy to understand. I hope you are enjoying the series. We are covering Domain 3, Security Architecture and Engineering. So we are discussing least common mechanism here. This is an important design principle and it refers to some of the concepts which are also very important in terms of CISSP exam. So let's understand what is least common mechanism. Least common mechanism, if you look into this sentence, it has got three words: least, common and mechanism, right? Mechanism, we already know. Mechanism is the way some system works in its totality, right? There will be different components inside the system, and these components kind of depend on each other to achieve one common task, right? This whole collection of objects, subject, common mechanism, and the combination of hardware, software, firmware in achieving something unique, this whole orchestration is called mechanism. So least common mechanism means that any component which is shared between different components or between different subjects, between different users, that sharing of component has to be avoided. If we can't avoid, we have to minimize it, right? What it means in a very practical sense. So if you look into one very good example, I will give you the example of internet. If you look into the internet is one thing which is commonly shared between all the users who are browsing internet, or all the company who are doing business on internet. So internet is the common mechanism in achieving something which is online business or online presence or whatever you can think of, and internet is the most common mechanism, right? So the principle of least common mechanism says that we should avoid something which is common. Can we avoid internet? The answer is no, we can't avoid internet. Now what we can do, if we look into the perspective, look from the perspective of risk, or from the perspective of potential threats from different attackers, we will realize that internet is the common mechanism, right? So if there is a company, it has got an internet gateway or internet firewall, and it connects to internet. Now internet is common for every user, whether it's an attacker or a business partner or a vendor or anyone. Now if we have to avoid a least common mechanism here, what we should realize that it's impossible to do in the very first place. What we can do from a company point of view, if we want to mitigate the risk of dependency on internet, or risk of mitigating the attacks coming from different attackers on the internet, we can have two different internet connection for the company. It will give the internet redundancy, plus if an attack is doing some distributed denial of service attack on the company from ISP A, the company can be safeguarded from ISP B, right? So this is one example for you to understand what is least common mechanism, what is common mechanism first. And the principle of least common mechanism says that we have to minimize the usage of common mechanism, right? So that's one way to understand. Another way to understand least common mechanism is like in any networking environment. When you have a network design, what we see that the network is designed in a way that it has got a core layer where you have your WAN services or different connections, and then you have got an aggregation layer, and then you have got an access layer, right? So this is a typical three-tier architecture. Now aggregation layer is a common place, right, for users, servers, or IT management services, file servers, or Active Directory, proxy, DMZ. So the middle layer, aggregation layer, becomes a common factor. Now principle of least common mechanism says that we have to avoid something which is being shared by different users, right? Can we avoid aggregation layer? The answer is no, we can't avoid aggregation layer. If we avoid aggregation layer, it means that we don't have a common place where we can have different services which will be acting in a way to let access talk to core, right? So we can't break this hierarchy. Instead, what we can do, we can create different silos in aggregation layers, and we can have different security level assigned to them. So I can have an aggregation layers which handles the traffic of end user, and we can segment a different aggregation layer which can handle the traffic for production server, and a different aggregation layer stack which can handle the common IT management services like file server, print server, or like the jump box where you can log in and further log in into different production systems. I hope you can understand with this idea that the principle of least common mechanism, which states that we have to minimize the usage of common mechanism, but practically it is not possible in all the situations. We always have common mechanism, but we can smartly segment the common mechanism. We can go for virtualization and we can go for isolation. So these are different techniques. The common techniques for achieving the least common mechanism, or to to avoid a situation of having common mechanism, or to minimize the usage of common mechanism, which is least common mechanism, is by having sandboxes, by having virtual machines, or by segmenting the network. Or in the case of microprocessors, CPUs, we can have different registers, different memory allocations, which can talk of specific processes, common processes to handle. Nowadays we have this purpose specific integrated circuits, and then we have graphical processes unit which can take load of central processes unit at times. So these are the techniques which are used to achieve the principle of least common mechanism. Now, why mechanism should not be shared, as I already explained, is it gives rise to a situation where information can flow along shared channels, and it gives rise to covert channel. What is covert channel? Covert channel is basically an unnecessary path, or a path which is created by having not proper security measures in place. Even you segment your network in a very proper way, but there may be situations that if a server is having its own routing enabled and you have two different segments segmented by a firewall, the server can route the traffic by its own, bypassing the firewall. So those kind of situations are called covert channel, right? So mechanism should not be shared because it gives rise to covert channel, and information can flow along shared channels, right? Least common mechanism focus on not sharing the common component, and if we can't stop sharing the common component, at least we should minimize the sharing of components between users. We should be aware of the transitive trust, right? So the transitive trust is something which is more like when I recall my school days, we study something called the laws of thermodynamics, right? So law of thermal equilibrium. So if A is in a thermal equilibrium with B and B is in thermal equilibrium with C, I can say that A and C are having the same temperature. So that kind of thing is called transitive trust. In information security, what we say, that if a system trusts B, if a system A trusts B and system B trusts C, then in turns A started trusting C. One common example is the root certificate, right? So if you are opening a bank website, you are trusting the bank website because bank website is trusting the digital certificate produced by a digital certificate authority or digital certificate signing authority, right? So your trust on a bank website is dependent on bank website's trust on the certificate authority. So this is a transitive trust. Can we avoid transitive trust? The answer is No, we can't avoid transitive trust. This is the foundation of having the public key infrastructure, in internet, right? So the way we can't avoid internet, we can't avoid transitive trust. But what we can do here, we can look into the transitive trust from a risk point of view, and we can see, what potential risk can be thought of, like, is there a man in middle attack which can happen with the transitive trust or not? Or if we are doing a transitive trust, then the entity or the vendor where we are putting our trust transitively, how secure is that company, how secure is that vendor? We can go for security a scorecard if we like, and see that how is the company's security performing. Are they doing proper patch management? They are doing proper application security? They do have like proper network security? So those kind of things we can do an assessment. We can refer to SOC reports if we like. So these are all due diligence and due care exercise we do in order to have proper confidence in the transitive trust, right? So the moral of a story is, you can't avoid having a common mechanism in today's practical world. You can't go for a situation where you don't have any component which is not shared. You know that your proxy server in your organization is always shared between different users, and even if a server is downloading a patch from some vendor, it's using proxy. So the proxy server becomes the common gateway for your users and servers as well. What we can do, there is a risk that a server is downloading some file and a user is also browsing internet, going to Facebook. You can have two different proxy server. You can segment the proxy server, one for critical server and one for users, right? Because they will have different security classifications. Your production server may be handling data which is privacy sensitive data, or which is a data which is very confidential in nature, right? So you don't want that server exposed to the same proxy server which is being used by end users, right? So those situations has to be analyzed, has to be documented, right? So that's the way we can avoid a problem arising due to least common mechanism, right? I hope this principle is understood, and best of luck for your CISSP exam. Let's meet in the next video where we will be discussing a few more design principles, and then we will be going into ISO IEC design principles. Thanks for watching the video, and best of luck for your CISSP exams.